Hi there. 2D shapes, two-dimensional shapes. Are we okay with what two-dimensional means? Well, if you're not too clear on that, basically we're talking about flat shapes, okay? We live in this three-dimensional world where we can move around in three-dimensional space and things have three dimensions, okay? Two-dimensional means there's only two dimensions, and let me show you what I mean by that. If I were to make a dot, which you can barely see, that little dot right there has 0 dimensions, okay? It's just a dot. It doesn't have any length, it doesn't have any width, and it doesn't have any depth, okay? Now, if I were to extend that dot straight down in only one, now it has one dimension, okay? It has maybe length, I could call it length. And then if I took this one-dimensional item, which is just a line, and I took both of its corners and I extended them out this way, I took that whole line and just spread it that way, I would have a two-dimensional object, okay? And in this case, it's a rectangle. Now, later on in the next unit, we'll talk about three-dimensional objects, and that's when you take this whole face right here, the whole plane, and you push it. You push the whole thing out, and that's when you get your third dimension, okay? A cube or a rectangular prism. We'll talk more about those later though. Right now we're gonna spend time with just the two-dimensional objects. And the reason we call them two-dimensional objects is because they have two dimensions. They have two different things we can measure. In the case of this rectangle here, which is a two-dimensional object, it has a length and a width. Okay? And in fact, this should be kind of a review for you. If I were to ask, what's the area of this rectangle, how would you find that? Well, first you need some measurements of the dimensions, right? So let's say that this dimension, the length, has 3 inches. This is 3 inches. Obviously, it's bigger than that on my board, but we'll just use that as an example. And then this one down here, the width, is 5 inches. So here are my two dimensions for my two-dimensional object, okay? And from here, I'm trying to figure out if I were to cut these things up into their measurements. Let's say this is 1, 2, 3 inches, 1 inch, 2 inches, 3 inches. And over this one right here is 1, 2, 3, 4, and 5 inches. Then I can basically just draw lines all the way across for that one, all the way across for that one. And then down here, go up, 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 and up. And I've basically taken all of these measurements and made a bunch of squares, right? Which makes sense because when I'm measuring the area of a two-dimensional object, I just want to know how many squares are inside. In this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In other words, 3 times 5, right? So the area of this rectangle right here is 15 inches squared. Or another way of saying that is 15 square inches, because that's what I did, right? I cut this into square inches, or inches squared. And there's 15 of them. That's why your answer to an area problem always has to have that little square next to there, because you're counting squares. You'll notice when we get into the 3D objects, you're counting cubes. But let's not get ahead of ourselves, okay? Now, this lesson is not called rectangles, and that's because rectangles is probably more 5th grade type stuff. Finding the area of a rectangle like this is generally considered to be a 5th grade skill. This is called parallelogram. Have you ever seen a parallelogram? I actually have a printout right here. If you can see that. It kind of looks like a rectangle, doesn't it? But it's kind of shoved. It's kind of leaning. So basically, I could take this rectangle and I could just kind of push the top. Let me see if I can get you a good drawing of that. I'm going to take this rectangle and I'm not going to change anything about it except its general shape. So I'll push that over a little bit there. I'll push this a little bit there. And here are the sides that were originally part of a rectangle. All I did was give it a little shove. It's just leaning. But the area is still the same, okay? The area is still the same. Now, since that's true, here's a cool little thing I can do with that. I haven't really changed, I mean, this will have changed. If I took that 3-inch up and down line and I gave it a shove over that way, it would change this. But let's not worry about that too much. That's a little bit more advanced mathematics, okay? But if this was a 3-inch side, actually, that's not what I wanted to say. If this was a 5-inch width, okay? That didn't change at all, right? When I pushed this little guy over, this didn't change. I didn't make this longer, I didn't make it shorter, I didn't do anything weird to the bottom. The base, this is an important word, didn't change at all, okay? Now this side did, because when I pushed it over this way a little bit, it stretched a little bit. But I can still use the original measurement. Remember that up and down, straight up and down? Because look at this line right here. That's still 3 inches. This straight up and down line is still 3 inches tall, okay? And I call that the height. All right? I'm not even really gonna worry about this side right now because it's different now and I don't wanna use it. But nothing else about this rectangle changed when I leaned it over to the side. The area is still the same. How tall it is, its height is still the same, and the base didn't change at all. So now I'm not gonna use length times width anymore, right? I'm gonna use the height, that original up and down line, which used to be the length, and this width, which I'm now calling the base. So the area of a parallelogram, the math is exactly the same as a rectangle. But instead of length times width, now you're multiplying base times height. The bottom times how tall it is. In fact, you know, I wish that when they started teaching area of rectangles, they just called it base times height. I think it would be so much easier instead of length times width, because even with a rectangle, you're still dealing with a base and you're still dealing with a height. And then when you start talking about parallelograms, when you just kind of lean the rectangle over a little bit, you're not changing anything. It's still base times height. And actually, you're going to notice that as we start talking about geometry in this course, from parallelograms to triangles to trapezoids, it's all about bases and heights, okay? There aren't really any lengths and widths to talk about. So this is how easy parallelograms are. I wanted to give you a background of where a parallelogram comes from and where this comes from. So when you're given a base measurement and a height measurement, you just multiply. 5-inch base, 3-inch height is 15, and we're still using inches, and of course we're still counting squares. So the answer to what is the area of this parallelogram, which was made from a rectangle earlier, is still 15 inches squared, okay? What if I were to ask you this, before I let you get into the practice? What if I were to ask, what is the base? Let's say I don't know this, so I'm just gonna put B. What is the base of this parallelogram if the height is 5 centimeters and the area is 35 centimeters squared? Think you can figure that one out? Think about how you found the area last time. You took the height times the base, right? And that equals the area. That was equal to area. So now let's look at this little formula right here and let's fill in the actual values that we know. This time we know the area, right? So over here I would say 35 equals, I don't know B yet, so I'm going to leave this one as B, times 5. Do you see how we're solving an equation now, just like we were before? And we can actually rewrite this so that it's a little more comfortable because B times 5 is just the same as 5 times B, right? If you don't want to, or if you're comfortable saying, oh, well, 5 times what equals 35? Easy, then you can just do it that way. But if the numbers get a little messy for you, you might want to go ahead and set it up in a form that you're a little more comfortable with, okay? Because then I'm just using inverse operations to find B, right? Since 5 is being multiplied by B, the inverse of multiplication is division, and I have to divide by both sides. So 35 divided by 5 is 7, which means that the base is going to be 7 centimeters. All right? And remember, the base is a distance. It's one dimension, so I don't have to put the little square right here. The only time you're going to use the square label is when you're talking about the whole area of the shape, okay? So there's two different ways I was using the parallelogram formula and where that parallelogram formula comes from. So go ahead and check out the practice underneath, and I'll meet you on the exercise review video. Good luck.